Welcome to Metrology lecture series. In the previous lecture, we discussed the gate tooth measurement by chordal thickness method, constant chord method, and the base tangent method. In the present video, we will discuss the numerical problems on gate tooth thickness measurement. Let's see the first question. Calculate the setting of vernier of the gear for a straight spur gear having 40 teeth of module 3 pitches. So in the question, we have to calculate the setting of gate tooth vernier caliper. So this is the gate tooth vernier caliper. So there are the two setting is required. One is the chordal thickness W and the chordal addendum small d. So we know the equations of the W and D. So let's observe the given data. So in the data it is given the number of teeth is capital T equal to the 40 and modulus small m equal to the 3. So in the equations of the W and D, so it is the involving the m and capital T. So in the data already it is given the m and T. So then we have to directly substitute the m value and capital T value. We will get the chordal thickness as well as the chordal addendum. So first we have to go for the chordal thickness. W equal to the mt sine of 90 divided by capital T. So here small m is the 3 and capital T is the 40. Then chordal thickness W equal to the 3 into 40 into sine of 90 divided by 40. If we solve this one, we will get the chordal thickness is the 4.711 mm. So next we have to calculate the chordal addendum small d. So small d equal to the m plus mt by 2 into 1 minus cos of 90 divided by t. Then substitute the m and t values. Then small d will become the 3 plus 3 into 40 by 2 into 1 minus of cos of 90 divided by 40. And if you solve this one, we will get the answer is small d chordal addendum small d equal to the 3.047 mm. Let's see the second question. Calculate the chord length and its distance below the tooth tip for a gear of module 4 and 20 degree pressure angle. So we have to calculate the chordal length as well as we have to determine the distance below the tooth tip. So let's consider chordal length is the C and distance below the tooth tip is the small d. So I have to calculate the C and D. So this question is belongs to the constant chordal length method. So we know the formulas. So chord length small C equal to the pi m by 2 into cos square pi and small d equal to the m into 1 minus pi by 4 cos phi sin phi. So let's observe the given data. So here it is given the module is given m equal to the 4 and pi is given pressure angle that is the 20 degrees. So observe the chordal length and the distance below the tooth tip small d. In the two equations, these two equations are involving the m value and pi value only. So in the data it is given the m value as well as the pi value. Then we have to substitute these values, we will get the answer. So first we will go for the chord length. So C equal to the pi m by 2 into cos square phi. So here we know the m value and phi value pressure angle. Then substitute, then C will become the 1 by 2 into pi into 4 into cos square 20 degrees. If you solve this one, we will get the C value is the 5.55 mm. So next we will go for the distance below the tooth tip, that is the small d equal to the m into 1 minus pi by 4 cos phi sin phi. So substitute m equal to the 4 and phi equal to the 20 degrees. Then if you solve this one, we will get the small d value is the 3 mm. Let's see the next question. The following data is available for the measurement of chordal thickness of a gear having an involute profile. The number of teeth is 32. Addendum circle diameter is 136 mm and pressure angle is 20 degrees. Then determine the chordal height to which the gauge tooth caliper should be set during measurement. So here you have to determine the chordal height. So while the measuring of the gauge tooth thickness by using of gauge tooth vernier caliper. So here you have to determine the chordal height or chordal addendum, that is the small d. So we know the equation small d equal to the m plus mt by 2 into 1 minus of cos 90 divided by t. So let's see the data, what is they are given. So in the data it is given the number of teeth capital T equal to the 32 and addendum circle diameter 136 mm, pressure angle phi equal to the 20 degrees. So in the equation small d equation, the equation is involving the m and t, but in the data t is given but m is not given. So have to calculate the module m value, have to calculate. For this one I have to use these two formulas. One is the first relation is pitch circle diameter small d equal to the m into capital T. Maybe you have to use the another equation m module m equal to the addendum circle diameter divided by t plus 2. So among these two equations we have to use the second equation because here addendum circle diameter is given. Then small m value will become the addendum circle diameter 136 divided by number of teeth plus 2, that is the 32 plus 2. So small m will become the 136 divided by 34, which is equal to the 4. So module equal to 4. So we know module m and also number of teeth capital T. Then these two have to substitute in the small d equation. Then small d equal to the 4 plus 4 into 32 by 2 into 1 minus of cos of 90 divided by 32. If you solve this one, we will get the chordal addendum or the chordal height, which is small d equal to the 4.077 mm.